Wicked. Yeah. No need for the biscuit, the E gets wicked. Yeah. No need for the biscuit, the E gets wicked. Yeah. No need for the biscuit, the green light on the fire, brother coming wicked. I set the mark off just like anger, rape the funk floor. Yeah, body off the swing. I put the lotion to the motion, drop the funk, coast to coast, and I buck like shot because I know I got you open. I drop the mic like Snoop. I get stuck like town when I knock the boot.
So the first thing you need to learn is what it means to square a number in mathematics. What I'm going to do is quickly write the definition so that you can see what it means. So we annotate square by the little number 2 above something. And all that it means when we write this is you take what's underneath the 2 and you multiply it by itself. So just as a quick example, 6 squared, that's just 6 times 6, because it's under the little 2, which is equal to 36. Another quick little example. So you can probably see what's going on. I'm going to write another example, and I want you to pause the video and try and figure out what it is before I show you the answer. Okay, so you should have written something like this. Remember, what's underneath the little 2, you multiply it by itself. So 9 squared would be 9 times 9 is equal to 81. Okay, so now that you know the definition of squaring, you should be able to apply that idea to binomials. So if your teacher gives you something that looks like this, your first instinct should be to use the definition of squaring that little 2 to rewrite it like this. Therefore, it's definitely not equal to what a lot of you want to do, which is just bring the little 2 down and square each inner term. Because of our definition of squaring, these two things are not equivalent. I want you to remember this especially because this trips a lot of people up. It's just rewriting it as whatever is underneath times itself. I want to talk to you guys a little bit about distribution. Distribution is just this familiar property of being able to take something outside parentheses that's being multiplied by them and apply it to each inner term. So what that means is the 7 gets multiplied by the x, and it also gets multiplied by the negative 4. These two statements are equivalent because of the property of distribution. But in fact, up here, this x plus 3 could be thought of as its own 7. So what I can do from this step is think of the x plus 3 as its own 7 and apply it to each inner term on the other binomial. So you get x plus 3 times x, and then you get x plus 3 times 3. So quick practice question, just to bring you guys up to speed. Try this binomial out. I have to turn this into a letter. Yeah, star. We'll make it a star. Try this out for yourself. Okay, the first thing you should have done is use the definition to rewrite it, and then think of this as its own term and apply it to the other terms. You get 7 minus star times 7, and then this part probably tripped you up, but what I'm going to do is think about it as negative star times 7 minus star. That's kind of what I'm doing up here. I'm thinking of it as negative 4 times 7. You can think of it as either way, but this way is nicer to write. So you get 7 minus star here. Okay. So once again, this is squaring, and then this is using the distribution property on binomials. So now I'm going to come back to come around to the foiling part. A lot of you know how to, or at least can use the method of foiling to square binomials. But here I'm going to show you where that comes from, using distribution again. So like from before, the 7 can just get distributed in here, so we get 7, well actually here's a good way to use 7 squared, minus minus 7 times star minus, now I'm distributing over here, minus star times 7, and then minus star times minus star would be plus star squared. Okay. Really, this is just foiling, right? So here's first 7 times 7. Here's inside negative 7 times star. Well, the negative gets switched around, but it's the same thing. And then you get negative star times 7. That's let's see, FOI. That's inside, and then L would be these two things. So really, foiling is just distributing twice, and then we can collect like terms here. So we've just ran through the whole process of squaring this weird looking binomial. So here's a practice question to try your skills out. I want you to pause the video and try this for yourself, remembering all the things in the video that I've already talked about. I'll write them down here so you can keep them in mind. Okay, so you should have tried this out on your own and follow along with me, and if you didn't get the same answer that I'm getting, think about why you did and check it against these three things: squaring, distribution, and negatives. First thing, use my definition of squaring. All I'm doing is rewriting this according to our definition. Then I'm gonna run out of space here. Move down here. These two things are on the same line. All I've done here is distribution once, and then I'll do distribution twice. This first line is this distribution, second line is this distribution, and then all on the same line, I'll gather like terms. Okay, so that's how to square binomials. If you guys can do this binomial and you were able to follow through this, then you'll be able to square any binomial that your teacher throws at you. If you like the video, please smash that like button, and hopefully there will be more videos in the future. Any feedback is appreciated. If anything was too confusing, please tell me what, and I'll try and do that better in the future. This is a 4, and that's a star, so have a good day.